In this video, I'll be looking at solving systems of linear equations. I want to remind you that these are just overviews, so I'm not going into as much detail as I would on some of the other videos I've done. And I do remind you that I do have other videos on this channel and also on my Dr. T Math and More channel that will go in more detail. You want to look at those. I also have videos on how to solve systems of linear equations using a graphing calculator, which are very easy to do. Okay, if your instructor lets you use them, say in a multiple choice test or something like that. But sometimes they want you to show the work, so you have to be able to do it. So again, graphing calculator, yeah, 80 through 84, also the TI-89. So you can look at this channel or my Dr. T Math and More channel for that. Now, the word linear, of course, refers to a line. So we're going to look, first of all, at systems of equations with x and y first degree. So that means the graph is going to be a line. So if you take any line or any two lines and graph, you're going to have three scenarios. So the first one that I have here, I have two lines intersecting at one point. You have one solution. At that particular point, it'd be an ordered pair xy, assuming we're using the variables x and y. Now, if the lines coincide, in other words, the two equations represent the same line, you'll have the second diagram here, the lines intersecting, so you see just one line, so you have an infinite number of solutions. Now, if it turns out that the lines are parallel, you have the third diagram where the lines don't intersect, so in that case you have no solution. So normally you're going to have two equations with two variables, three equations with three variables, four equations with four variables, and so on. It's possible, though, that you'll have more variables than you have equations. Okay, so in the main scenario, you're either going to have one solution, an infinite solution set, or no solution. That is, the lines do not cross. So typically your equation in two variables, first degree x and y, has this particular form: ax plus by is equal to 6, or is equal to, say, some constant c. Now, if it turns out that the a is 0, that you don't have an x, you just have a y, that's a horizontal line. If it turns out that the b is 0, you only have an x in the equation, so that's a vertical line. Okay, so normally we say that both a and b cannot be 0. Okay, otherwise you're not going to have a line. Okay, you may just have a contradiction. So if the equation of line will take this form, it could be a vertical line, it could be a horizontal line, it could be a slanted line. So as an example, we look at, say, x plus y is equal to 6. Now, if you're just given one equation like this one is going to have an infinite solution, right? You can have one solution would be 6, 0. Yeah, you could have, say, 0, 6. You could have 3, 3. X is 3, y is 3. That's going to satisfy the equation, and so on. In other words, just pick any value, say, for x, or pick any value for y. So we pick x to be 1, put a 1 where the x is, subtract the 1 from the 6, we get y is equal to 5. So that's going to be a solution. Okay, so I can do that forever. Right? Just pick a value for x or pick a value for y, and we get the solutions. Okay, it's infinite. So a lot of times we'll just give a formula and say, okay, the solution set for this would be any ordered pair xy and then I just solve one of the variables, either the x or the y. So I'm going to solve it for y and say y is equal to 6 minus x. And this is where x, say, is any real number. I'll just say it's real. So this would tell me, okay, pick a value for x and you get a solution. You pick x to be 0, you get 6. Pick x to be 1, you get 5 for the y. Pick x to be 3, you get 3 for the y, and so on. Okay. So if you have more variables, than you have equations, then you're either going to have no solution or an infinite solution. That's always going to be the case. If you have more variables than you have equations, for example, if you have just this equation with x and y, we have two variables, but only one equation. This is going to be infinite. Okay. In the scenario where you have the same number of equations as you have variables, then it'll be one of these three scenarios: either one solution, infinite solution, or no solution. Okay. So I want to remind you that there are many ways to solve systems of equations. Okay. You can use elimination method. You can use a substitution method. You can use determinants. You can use matrices. Okay. You can use your calculator. Okay. So there's many solutions. In this video, I'm just going to focus basically on the elimination, a little bit of substitution. So let's look at the first one. The first three are going to be systems of two equations with two variables, x and y. Okay, it doesn't have to be an x and y, it could be p and q, but typically we use x and y. Okay, so when I use the elimination, which is what I'm going to do here, basically we're using the properties of equality. So if I have, say, two numbers a and b, and I say those numbers are equal, a is equal to b. If a is equal to b, then I can add the same number to both sides, say c, and I still have equality. Or I could subtract the same number from both sides, and I still have equality. Or I can multiply both sides by the same number, as long as I don't multiply by 0, because that wipes everything out. Okay, so those are properties of equality. Okay, so let's clear this. So when we solve something by elimination, again, what you want to do again, and I remind you also that if it turns out that the equation has fractions in it, just multiply both sides of the equation by the lowest common denominator to clear the fractions and simplify as much as possible. So generally you want your system to look like this. You want the variables, the x and the y and b, to be in one side, and you want the constant or the number to be in the other side. Okay, and then you choose to eliminate either the x or the y from the equation. It doesn't matter which. So in this case, I'm going to look at this and say, well, okay, if I want to eliminate the y, I could multiply the first equation by 3, because that would put a 3 right there. Minus 3y and a 3y will cancel. A little bit harder to eliminate the x, but you can do it. Okay, but I'm going to multiply through by 3 here. Okay, so this will become a 15x minus 3y is equal to 39. Okay, and then I see that the minus 3y and the 3y will cancel. So I go ahead and do that. So 3 times the 5x is the 15x, and 2x is 17x. Okay. And then 3 times the minus y is minus 3y, but if I add that to the 3y, that cancels. So that's 0. I'll just leave it out. And then 3 times 13 is 39. Add 12 to that, and that gives me 51. Okay. So what I've done then by elimination, then I've eliminated the y variable, and I've obtained an equation with one variable x. So it's easy to work with an equation if it has one variable. So now I just divide through by 17. Okay, this cancels out, and then 51 divided by 17 is 3. Okay, now I got x, so now I could get the y the same way by eliminating the x. So what I could do in this case, I could multiply the first equation by 2 and the second equation by minus 5. Okay, notice 2 times 5x is 10. X minus 5 times 2x is minus 10x. So if I go ahead and compute that out, the x is going to cancel. Okay, so again, 2 times 5x is 10x, minus 5 times 2x is minus 10. Those cancel out. So now let's look at this. 2 times minus y is minus 2y, minus 5 times 3y is a minus 15y, so minus 15y, and minus 2y is minus 17y. Okay, and then 2 times 13 is 26. Okay, put that up here. Okay, and then minus 5 times 12 is minus 60. Okay, 2 times 13, 26, minus 5 times 12, minus 60, and then we add these. This will give us a negative 34. And then divide negative 17 into negative 34, we get y equals to 2. Okay, so the solution set consists of x equal 3, y equal 2. So we can give the answers x equal 3, y equal 2. We can write it as an ordered pair, or we can use a solution set like this. Okay, and the thing about it is easy to check. Put a 3 where the x is, put a 2 where the y is, and make sure you get 13. Put a 3 here where the x is in the second equation, 2 where the y is, and make sure you get 12. And make sure you check both, because it's possible you made a mistake and you got one of the equations to check, but the other one doesn't. Keep in mind, each equation by itself has an infinite solution. Okay, so it's possible that you made a mistake and you got an answer that works for one equation but not the other one. Okay, so it's essential that you check both in this particular case, especially if you think you made a mistake. Now, also keep in mind that instead of eliminating the x here, I could have just substituted x equal to 3. So I could have gone to the second equation and put a 3 where the x is. It's okay, 3 times 2, that's 6, plus 3y is equal to 12. Subtract 6 from both sides here. I get 3y is equal to, okay, after subtracting the 6, so 6 from 12 will give me 6. And then 3 into 6 would be 2, so I get y equal to 2, which is what I would have done. Okay, I wanted to show you both methods, but this is what I've done here. So I did the elimination and then a little bit of substitution, and I get the same result. Okay, So if you were to draw these two lines, if you were to graph these two lines, they would cross or intersect at the point 3, 2. Okay, 3, 2. Clear this? Let's look at the next one. Okay, again, keep in mind that they're not always going to be in this particular form. So if you're doing the elimination, you want the variables on one side and the constants on the other side. If you have any fractions, go ahead and multiply through by the LCD, kind of like we did in the first video. Makes it easier to solve the equation if you don't have any fractions. Okay, so on this one, again, I'm going to eliminate one variable. So I'm going to say, okay, let's eliminate the x by multiplying the first equation by 3. So you multiply through. Now, if you want to go ahead and rewrite it over here, you can. You can say, okay, multiplying by 3, so this becomes a 3x minus 3y equal to 15. Okay, and then the second one stays the way it is. So again, what we're doing is we're using the elimination method, multiplying one equation by a number, or in some cases you multiply both equations by a number, and you want to select the number so that when you add the two equations, one of the variables, at least one of the variables, cancel. Now I say at least because notice in this particular case, both variables are going to cancel. 3x minus 3x cancels to 0, minus 3y and 3y cancels to 0. 15 and 2 is 17. Okay, so notice in this case I don't have a variable. I have a contradiction. 0 is equal to 17 can't be a true statement. Okay, so this is the scenario where the lines do not intersect. If you were to sketch a graph of these, they would be parallel. So this is the case where you have no solution. Now sometimes you'll hear the word inconsistent, or the system is inconsistent, or you'll hear the word consistent if the system has a solution. Okay, whether it's infinite or just one solution. Okay, so consistent refers to the system having a solution. Inconsistent system refers to no solution. So in this case we have no solution. Now, in the next one, again, we want to eliminate one of the variables. So I'm going to multiply the first equation by -2 to cancel the x. Okay, so that'll be a -2x and a 2x. Notice they're going to cancel. But also when I multiply the second term of each equation, it's -4y and 4y. That also cancel. So that's going to be 0 on the left side. And -2 times 4 is -8. And 8 gives me 0. So in this case, I get no variables, but I get 0 is equal to 0. Okay, whenever you have something like this, you get a true statement, but you don't have a value for x or for y. Okay, you just get a true statement. 0 equals 0. This is telling you that the system has an infinite solution. In other words, the two equations coincide. Okay, or another way to say it, it's the same line. It's the same line. So it's infinite solution. So normally if it's infinite, your instructor might expect you to give a formula. Okay, so again what you would do here is you would say, okay, my solution is infinite, so I'll give the formula such that xy, and then what you do is you take either one of these. It doesn't matter which one because they're the same equation. So I'm going to take the first equation and solve it for x. So 2y is equal to 4 minus x. So I'm actually solving for y, and solving for y in terms of x. Okay, then I divide by 2. Okay, so the solution set is infinite. So we'd write it like this. It's a set of ordered pairs x, y such that y is equal to 4 minus x over 2. And here I would just say x is real. X is any real number. Okay. Now I solved it for y in terms of x. I could have solved it for x in terms of y. Okay. That would also work. So in other words, I could say here x, take the first one, solve it for x. X is equal to 4 minus 2y. And put that in here, and then I would just say y is any real number. Okay, because the way this works is, okay, this is your formula. So if you want a solution, you just pick a value for x. Okay, so say, okay, give me one solution. If it's infinite, give me one solution. Okay, so pick x to be 0, and you get 4 over 2. So 0, 2 is one solution. You can see, put a 0 there and a 2 over here, I get 4. Put a 0 there and a 2 there, I get 8. So it checks with both equations. It's infinite. Okay, so you can't list all the solutions, but you can give a formula that will generate as many solutions as you want. Okay. So these are the three scenarios that you're going to get when you try to solve a system of two equations, two variables. And remember, these are first degree equations. The x and the y have to have powers of 1. When you try to solve an equation with two variables, you're either going to get one solution, no solution, or an infinite solution set. Now, the ones that are easiest to solve are the ones that have no solution, because there you just stop, very little work done. The ones that have an infinite solution, you have to normally your instructor will want you to give a formula. Now, if you have, say, three equations with three variables, you're going to have the same scenarios. Okay. So what do we do with the two equations, two variables? We eliminated one variable and got it down to a single variable. Well, you're going to do basically the same thing. You have three equations. You want to reduce it down to two equations with two variables, and then eventually one equation with one variable, and then you solve for all of them. Okay. So in this one we have three variables. So I'm going to eliminate the z. Okay, so what we want to do then is the procedure generally is you take two of the equations. So I'm going to take the first and the second and eliminate one of the variables. Okay, and you can choose whichever one you think is easier. So I'm going to eliminate the z from the first two. So I'm going to multiply the second equation by 2 and then add the 2. And notice what's going to happen. So again, just mentally, 2 times 3x is 6x, and then 2y, then multiplying the negative 2z by 2, I get minus 4z. So if I do that, I'm going to get, notice, 7x, because 6x and 1x, and then 2y and minus 2y cancel. A minus 4z and a 4z cancel. And then a 2 times a negative 1 is negative 2, and negative 5 is negative 7. Okay. Now, a lot of times, only one variable will cancel, the one you're trying to cancel. Now, it turns out that in this particular one, the y also canceled. So it makes it easier. Okay? So now what you do is you take I took the first and the second, so now you take two different ones. So normally I would take, say, the second and the third. And you want to eliminate the same variable, okay? Because let's suppose the y didn't cancel here, then this equation would have had an x and a y. So we eliminate the z by multiplying, say, the second equation by 4 and adding to the third. Okay, so Again, 4 times 3x is 12x and a minus or 11x. Okay, so it's 4 times 3x is 12x, and minus x is 11x. Okay, and then 4 times y is 4y, and y is 5y. And then 4 times negative 1 is negative 4, and 8 is equal to 4. Okay, so now I get it down to 2 equations with 2 variables. And I do have the 2 variables, x and a y. Okay, so like I said, if the first equation had a y, then I would proceed just like the first one that I did. Try to eliminate the y or the x and solve for one of the variables and then substitute to get the other one. Now in this case, it turns out that the first one is easily solvable for x by just dividing by 7. So from there, I can just say, okay, divide by 7, both sides by 7, I get x is equal to negative 1. Okay. Now, take the second equation. I know x is negative 1, so I just do a little substitution here and put a negative 1 where the x is. This is negative 11 plus 5y is equal to 4. Okay, solve this equation for y, so I add 11 to both sides here. Negative 11 and 11 cancel, so I get 5y is equal to 4 and 11 is 15. Divide both sides by 3, or by 5 rather. So I get y is equal to 15 divided by 5 is 3. Okay, so I get x equal to negative 1. Y is equal to 3. Okay, now I need z. Okay, now I need z. So go back to the original equation. And you can pick any one of the 3 equations, either the first, the second, and the third, as long as it has a z, because we're looking for z. Okay. Keep in mind, sometimes they'll give you 3 equations, but maybe one of them will just have the x and the y, and the other 2 will have the x, y, and z. So always pick the one that has the variable you're looking for. So in this one, then I'm going to pick the first one. They all have the z, so put a negative 1 where the x is, so I'll get negative 1 there, minus 2 times y, and y is 3, plus 4z equal to negative 5. Okay, so I get negative 1 minus 2 times 3 is minus 6 plus 4z. Okay, so minus 1 and minus 6, that's minus 7 plus 4z is equal to negative 5. Okay, add 7 to both sides to eliminate the negative 7, and I get this side, I get 4z. And then 7 and negative 5 is 2. I divide both sides by 4. These cancel out. I get z is equal to 2 over 4, or 1/2. Okay. So my solution set is x equal to negative 1, y equal to 3, and z is equal to 1/2. You can give the answer that way, or sometimes you might want it as an ordered triplet here and put negative 1, 3, comma again, 1/2. Ordered triplet there. Or sometimes they might want it as a solution set, so put this within braces, and you have that. Okay, this gives you just a rough idea as to how to solve systems. Again, keep in mind that there are many ways to solve them. This is just a general look at how to solve them. Hope this helps you. Probably have one more video to do in this series, and that will be on systems of nonlinear equations. Okay, this would be like, say, one equation could represent a circle. Uh, the other one could be a parabola or something like that, and you're trying to find out where the two graphs intersect. You're solving the system. Okay, so keep watching out for those coming in a few days.